Good morning, dear educators. Welcome back with another interesting class. Here I am going to discuss of your class 11 mathematics. Okay, and in the previous class already discussed about the basic concept, definition, and introduction to set theory and the significance. Okay, and in this class I am discussing the exercise, first chapter, exercise 1.01. okay, over the concept of the basic concept of set theory, and which was already discussed in the first class from your additional book. So in this class I am discussing the solution of the class 11 mathematics chapter 1 from your additional book. I hope and you will continue watching, okay, and also practice the similar questions, okay, and understand the class, take the interest. Okay, exercise 1.01 chapter 1 set theory I am going to discuss. Question number 1. So look at the question. What is the difference between a collection and a set? This is one of the interesting question. What is the difference between a collection and a set? Okay, understand what is the difference between a collection and set. And in the first class already know the definition of set. Okay, what is the definition of set? Anyone can say? So as per the definition we know that the set is a collection of well-defined element. Yes, a set is a collection of well-defined element. It means a set is a collection, and it must be well-defined elements. But here is an example. Here is another collection. The collection of all the great cricket players in India. Is it a set? No, it is not a set. But the collection of all the cricket players is a set. Why? Because the collection of greatness is not well-defined, as it differs from person to person. Okay, and the collection of cricket players is well defined. That's why the collection of, okay, the set is a collection of well defined elements. So every set is a collection, but every collection is not a set. Why? Because you see, because the elements should be well defined. Thus it is clear that every set is a collection, but every collection is not a set. This is the basic difference between the collection and set. An interesting question over the concept of the definition of set and its collection. So every set is a collection, but every collection is not a set. Because every set is well defined, but every collection is not well defined. Okay. Here is question number 2, first bit 2.01 of exercise 1.01. Look at the instruction here. Which of the following collection are set? Justify your answer. A collection of all natural numbers less than 50. Is it a set? Okay. Yes. The collection of all natural numbers is a set. Less than 50 is a set, because we know what kind of elements are there in a set, and it can be written in the rooster methods, rooster form. We can write all the elements of natural number less than 50, and the elements are well defined. Thus a collection of all natural number less than 50 is a set, because the collection of natural numbers is well defined. As you can write the set as 1, 2, 3, 48, 49. So you can write the elements in the rooster method. The set can be expressed in the rooster form. The elements are well defined. Thus the collection of all natural number less than 50 is a set. Understand? Okay. Question number 2.02. Question number 2, second bit. The collection of all good hockey players in India. Is it a set? Is it a set? Yes. The collection of all good hockey players. Good hockey players. The word coming good. The collection of good hockey players in India is not a set because the collection of goodness is not well defined. And the choice of goodness differs from person to person, varies from person to person. Thus, the collection of good hockey players in India is not a set. But the collection of hockey players can be a set. The word goodness will vary from person to person, so the element of goodness, good hockey players are not well defined. Because a player may be good for one person, it will be different from other person. So the collection of good hockey players is not a set. Next question, question number 2.03. The collection of all the girls in your school, is it a set? Yes, you know. You can write all the name of the girls in your school and the elements are well defined. Thus the collection of all girls in your school is a set because the collection is well defined. Next question, question number 2.04, question number 2, bit 4. Okay. The collection of most talented writers in India, most talented writer of India. Is it a set? Do you think? Yes? No. Because the most talented writer is not well defined. Who is the most talented writers? It differs from person to person. The writer may be talented for one person but may not be talented for other. So the word talented is not well defined, not specific. That's why not universal, not general. That's why the collection of most talented writers of India is not a set. Okay, here is question number 2, bit 5. The collection of all difficult topics in mathematics. Difficult topics in mathematics is also not a set because the topics may be difficult for one student, may not be difficult for others, may be easy for other students. So the difficult topics, which are the difficult topics is not well defined. So the collection of difficult topics in your mathematics is not defined, is not a set because the collection is not well defined. Very basic concept about the definition of the set theory, which are the elements specific, which are the elements are well defined, which are elements are not well defined. If the element are not well defined of a set, then it cannot be set. Okay, next question 2.02, question number 2, 6 bit. The collection of all months of a year beginning with the letter J. Is it a set? Yes, it is a set because the collection of all the months in a year beginning with the letter J, we can write, the elements are well defined. Okay. Yes, the collection of all the month of year beginning with the letter J is a set because the collection is well defined. The set can be written January, June, July in the roster methods, roster form. Okay, and the elements are well defined. So it is a set. Question number 2, bit 7 here, which I am going to discuss. A collection of novels written by Munshi Premchand. Yes, it is a set. What are the novels you can collect and you can write, and the collection of novels written by Munshi Premchand is a set because the elements are well defined. What are the novels written by Munshi Premchand? You can write clearly, okay, in the form of set. Question number 208, 8 bit, question number 2.08, okay, 8 bit. The collection of all questions in the chapter in your mathematics. Yes, is it a set? The collection of all the questions in this chapter is a set. Because how many questions are there in this chapter, you can understand. Okay, you can ensure whether this is a question of this chapter or not. So the collection of all questions in a chapter is a set because one can ensure whether it is a questions of the chapters or not. Okay, so it is a set. Next question, a collection of most dangerous animal of the world. Is it a set, do you think? Yes? No, it is not a set. Because the word most dangerous is not well defined and it varies from person to person. Okay? So the collection of most dangerous animals of the world is not said because the most dangerous animals is not well defined and it varies from person to person. Basic question I am going to discuss here. Here question number 2 first bit I am going to discuss. Similar type of questions. Look at the question here. The collection of prime integers. Yes, it is a set. We know what are the prime integers are there. Yes, and the elements are well defined. What kind of elements are there? Can be in the set of prime integers. It is clearly understood and are well defined. So set can be written 2, 3, 5, 7. These are the prime numbers written in the Rooster methods. Can be written. So it is a set because the elements of prime integers well defined, specific. Okay, understand? Yes, these are the basic concepts student I am discussing, but these are the vital concept, basic concept of the set theory, and it gives the foundation to the deeper learning of the set theory, which is very important to learn. Question number 3 first bit. Here is the set notation. Using the set notation, belongs to, does not belongs to. Where you have to use belongs to sign, where you should not use does not belongs to sign. So here a set is given. A set A is equal to 0, 1, 2, 3, 4, 5, 6, 5, 7, 8, 9, 10. These are the elements. 6 is not there. And you have to insert appropriate option belongs to or does not belongs to symbol in the following branches. See, there is an element, 4 is an element and A is a set. Between the elements are written, must be written in the left side of the set, and set are written on the right side. Between an element and set, we always use belongs to or does not belongs to. Between two sets, we never use belongs to or does not belongs to. Remember the student. Between an element and a set, which sign you have to use? Belongs to sign or does not belongs to sign. You see, here 4 is clearly understood. 4 is an element of the set, which is already an element of the set A. So, since 4 is an element, we have to write 4 belongs to A. This is the notation, simple notation of the set theory, whether it is an element or not. If it is an element, we have to write belongs to. If it is not an element, you have to write does not belongs to. Look at the next question. Okay, question number 3.2. Second bit. Question number 3, second bit. Notation. Use of notation belongs to, does not belongs to. Here you see, here 12 is an element and A is a set. You clearly see 12 is not in the element, is not an element of the set A. If 12 is not an element of the set A, you have to write what? 12 does not belongs to A. 12 is not an element of the set A. We read 12 does not belongs to A. Okay? Understand? Similarly, here you see here 9 and A. Here 9 clearly an element of the set A. Since 9 is an element of the set A, we have to write 9 belongs to A. Okay? Basic notation of the set theory. First exercise, very simple exercise. Okay? So I hope you were enjoying and watching the class. Question number 3.5. Okay? A similar question, fifth bit. Here 0 and A. Here 0 clearly is an element of the set A. So you write what? Tell me. Belongs to. 0 belongs to A. Okay. Proceed to the next.